Okay, I think we can start it. It's noon time. We turn the lights down here. That's how we do it, right? Just that one panel?
I believe so, yeah.
Okay. Okay, welcome to our weekly weather discussion. This is the last one we'll have face-to-face. Next Friday, of course, is the Thanksgiving weekend, so we won't have a discussion even online next week. And then after that, everything is remote for the rest of the term. So this is the last live one that we'll have. Pete and I were just chatting, and some of you overheard us. Next semester, the discussion will be tied, I think, to AOS 753. So we don't really yet know who's going to be running that show, and we don't know where it's going to be. We were assigned this room, which has worked out fine, in the fall planning for, alternative classrooms. Perhaps they'll just give us the same thing again for next spring, but I'm not in charge of the class, so I'm not in that pipeline. We'll try to find that out, and everybody who's affected will get a notification about where to go next for that course and for the discussions in the spring. Okay, so that's, I think, the administrative detail I wanted to say today. So let's start with a look at the infrared satellite movie over the continental United States and adjacent waters here this morning. A pretty clear picture across the country. You'll see that's reflected in the radar summary too in just a minute. We have considerable convective looking activity south of Cuba, Jamaica, and I think there's even some suspicion that some of that might turn into the next tropical storm, which is just unbelievable. I don't know if that's still the case, and frankly I didn't look at that this morning, so I don't have any information more than that. Over the continent, there's a cloud street that goes all the way from Utah across the Midwest, just to the south of us over the Illinois-Wisconsin border, and then up into the maritime Canada portion of the map. And then there's a bit of a cyclonic cloud head. Doesn't look like a very deep one because the clouds don't look cold in this image, over Ontario, progressing across the province of Ontario. And we'll see in the surface map it's snowing in some of the stations just north of Lake Superior with the passage of that feature, but lightly, not heavy snow. And this whole cloud street clearly has an origin in the subtropics off the Pacific coast. And so in the forecast, it turns out I'm going to concentrate on two things and describe structural aspects of one of them and then developmental aspects of another. One of those features will develop as just a linear band of precipitation on the south side of an anticyclone with cold air coming southward in the Central Plains, I think during the day, Sunday, and then that will slowly develop really not yet under the influence of a fairly impressive upper wave that finally gets its act together over New England late in the day or midday on Monday, and then the thing explodes and runs up to the Labrador Sea. We get down to about 950 millibars. I think 34 of those millibars will drop out of the bottom of that thing in 12 hours or some ridiculous thing like that. So it's a really impressive development. The other feature I'll pay attention to in the forecast is a beautifully occluded storm that will, on Monday midday, crash into the Coast Range of British Columbia and the Panhandle of Alaska. Because there isn't that much to talk about in the central United States or even the continental United States over the next couple of days. That's the way it seems to be to me. Okay, so let's take a look next at the radar summary. And as I mentioned, you can see there's really not much radar echo anywhere across the country. We'll take a look at the surface map in just a second just to make sure that some of these echoes that are in the radar are actually falling in some of these locations as precipitation. It's not true everywhere. In fact, along the border that we have with Illinois, I think you're hard-pressed to find any actual precipitation hitting the ground. The dew point depressions are on the order of 10 to 20 degrees, so you're just not seeing any of that stuff come all the way to the ground. I think the same is true in northeast Missouri. It may not quite be true in the Puget Sound, but boy, aside from those few places, there's almost nothing on the radar summary across the country. And as far as I know, there's no malfunction of any of these radars. It's just the nature of the weather across the country today. Maybe a few of these features coming in off the Atlantic on the east coast of Florida will drop a drizzle or a little raindrop somewhere on the east coast of Florida, but that's about it. Okay, the next thing I had was the West Coast satellite image is dramatic, but also chaotic. Looks like a Picasso almost. There's stuff going on all over the place, but there's nothing that looks particularly like it should draw all your attention. But there's a cyclone well off the coast of central California that's kind of got an obvious circulation, higher cloud to the north and east, and then lower cloud on the back southwestern side of it. quite a bit of activity has been going on along about the latitude of the Aleutian Islands at about the date line. And yesterday, it's too bad we didn't meet yesterday, we had a beautiful cyclone sitting right over the Aleutians, and we had a nice description of that in our 452 class in the afternoon. And this is the remnants of that. So this circulation right here is the remnants of that very impressive cyclone. And the cloud street associated with its cold front is still well put together, and you can see it easily, very dramatically divides much colder air aloft. This is some really intense open cellular convection with pretty big spacing between the cells, indicating very cold at upper levels, and air that's quite a bit warmer to the east. But even right off the Queen Charlotte Islands, look at this little thing spin up in the cold air, right there. Beautiful, isn't it? So it's very active suddenly in the Pacific, Northeast Pacific Basin, although without a single giant cyclone today. That one's the one that was yesterday. And we'll see in the forecast about 3.5 days from now, along a fairly active, almost zonal jet, another disturbance goes through a really rapid development phase after a prolonged slow development phase. And I'll try and show you that elements of that evolution over the course of those 3.5 days as we go through the discussion. Remember, we saw that cloud streak coming across the southern states and then heading up towards the northeast. Looks like it has a connection anyway to these convective elements that are south of Hawaii. So this is like a 12 or 15 degrees north latitude, and it's coming from the date line all the way across. So pretty interesting, active Pacific Basin, not only active locally, but perhaps with an influence in remote locations.
There's a cyclone over there. I think the name is Polo, but I can't see it.
Where is there? Way off the map here?
Yeah, I just saw in the North American Center that they just mark an area and they call it Polo.
Maybe it's this thing. I don't know, so
Yeah.
I guess I don't know. Would it be at NHC? On their webpage? Let's see. Eastern Pacific,
Oh, yes.
Central Pacific. Well, at least not on this anyway, so. Oh, that's kind of interesting. Okay, I wonder what is going on there. So let's go to the surface map and a quick review only of some places of interest. Certainly where we live is of interest. We have 51/34. It's a pretty nice day here today. Even though the winds have shifted around to the northwest, they were southwest this morning, and likely so. And it isn't much warmer where they still are from the southwest. We're in the mid-60s in central Indiana, same dew points. And 68, well, St. Louis is a little bit warmer, but down here in Carbondale, 59. So it's not really in a different category than us. And neither is it much colder until you go way up to the northwest part of the state of Minnesota. You know, Minneapolis at 38 I guess that's colder than 51. But I wouldn't say it's in a different category, especially in the places where the sun's out. It's probably just as nice a day, but not so when you get further north. And you can see the snow in Ontario, rain in far eastern Ontario, and then snow also in Manitoba and parts of far western Ontario. So I don't see any snow reported anywhere in the United States. Well, actually, that's not right. Right up there in central North Dakota, there's one observing site with snow, perhaps tied to a more local feature and not the cyclone kind of moving across Ontario. Because I think when you look at Ontario, almost the whole province has snow except the far eastern portion of it. So many stations, even in unpopulated central and northwestern Ontario, reporting snow. 14/12, and that's what I'd like to be right now. That's pretty nice. Okay, I think we saw a little bit of precipitation on the radar in the Puget Sound region. Let's see if we can't see any evidence of that in the observations. So, moderate rain on the coast. What is the name of that town? I can't remember. I've been there a number of times. Kurt Cobain's hometown. Anyway, 47 moderate rain, some fog in other parts of the state and along the coast, and light rain at Nanaimo in the northern part of British Columbia. And yesterday was really interesting in our discussion. We had a temperature of 61/18 or something like that in Madison. No, it was 61/42, but it was 64/18 or something like that in Atlanta. Atlanta had a drier day than us by a long shot. Not today, it's about the same. So actually they're a little more humid than we are today, but they were well less humid than us yesterday. But a beautiful day down over the southern part of the United States. Here's some of that light rain that might be coming in on some of those sea breeze showers across Florida. Okay, that's probably enough of that. Then let's take a look at some of the upper level observations. Here's the 500 millibar map. I like to start there. This is from 7 a.m. this morning. So the first thing I notice when I look at it is it's a broad zonal flow across the northern half of the continental United States. That almost always means we're warmer than normal. You just almost can't avoid it. There's a mountain range that's like this, right across the continent, and the flow is just about perpendicular to it at mountain height. So there's a lot of subsidence and lee-side warming in the immediate lee. You don't see it in the 500 millibar isotherms, probably will at 850. So that tends to keep us warm. There's a local spot of pretty intense horizontal temperature contrast here, embedded just upstream of a little trough axis that's along the Mississippi River and on the western edge of the arrowhead. So I have a cross-section that I'll show you from Tropical Tidbits that is a forecast valid at this time, and we'll see what that thing looks like in just a second. And then with the fairly active weather that's recently been going on along and north of the Aleutian Island chain, you can see a pretty intense upper trough and a really remarkable horizontal temperature contrast associated with it. That's very sharp there on the western side of that trough. And right about where the minimum geopotential height line is, I forget the name of that island that's in the Bering Sea, but it's a sounding station too, 5,000 meter geopotential minimum, sitting right on top of the cyclone at sea level. So it's equivalent barotropics at this point and deeply occluded, although there isn't a really obvious occluded structure there. Let's see what it looks like at 700 millibars. No, 850 I guess is better for now. So with zonal flow across the high terrain, one sometimes sees a really big pocket of warm air across the central plains. Not quite today. That's interesting in and of itself. There's a little bit of warming going on maybe in the lee of the southern Rockies over Oklahoma, parts of Texas. But you can see with that very slight wave that we saw at 500 millibars, it's a little more amplified at 850 and not quite a closed circulation by any means, but along its front edge, there's a really nice 850 millibar temperature contrast. So we're 51 today, at noon time. We'll be lucky if we see 40 degrees at all tomorrow. Certainly we won't see it early in the morning. So there is going to be a frontal passage with a temperature drop, not just a wind shift, that's on the way. This is a few hours old. It might be just about on us right now. And so we'll see a substantial change in the temperature both in the late afternoon today and into the day tomorrow. There's the big cyclone north of the Aleutian chain in the southern Bering Sea. And it's the first of several. And there was a little disturbance here that I thought would look better on the satellite, but it really doesn't. I think maybe because it doesn't have much thermal structure, even in the lower troposphere. So cold advection prevails across the western Great Lakes states in the lower troposphere. That will change the complexion of the weather here as we head into the weekend, most certainly. And I think I wanted to show you, yeah, this cross-section. Let's go back to the 500 millibar map. So I'm going to show you a cross-section now from the gridded model analyses that goes from about north of Lake Winnipeg down to southern Illinois, right through the heart of that baroclinic zone. And we may come back and look at the jet in just a second. I just want to show you this now. No, not there. So here it is. And you get a sense of where I've cut the cross-section. There's Lake Winnipeg, and I went further, I guess, south in southern Illinois. Making the cross-section long gives it a really good aspect ratio. If you could take the same little snippet through the baroclinic zone, if you only went that far, you'll get an ugly structure. You won't be able to interpret it. So I'd encourage you to try that so that you'll never try it again, because it doesn't work. So you got to make them really long. So here's the PV, and the 2 PVU isotel is the dashed black line. The green lines are dry isotropes, and then the purple lines are isotax. So we have a wind speed max about 110 knots. It's not as well connected with the residual bit of upper baroclinicity that seems to be straggling here in the cross-section, approximately in this location. That's right where I showed you the strong 500 millibar temperature contrast. So this maybe had some history as an upper-level frontal zone. There's certainly strong horizontal and vertical shear through it, decent horizontal temperature gradient. There's even been some PV extrusion, apparently, but it's not robust. It's not any longer active as one of those features. It doesn't appear to me. And it's a fairly weak feature, and probably will have no impact on the weather across our region today at all. But just to show you that these things are really ubiquitous. You see them all the time. And even when they're weak, they're worthy of some discussion. So let's go back to one more level here. I want to look at, or two more. First 300 millibars. Here's the 300 millibar wind speed. And we saw that cloud streak coming across in the satellite picture. Some of it was right across the border of our state with Illinois, so in about this latitude. And it was obvious it came from the subtropics. This is probably a decent picture of the polar jet structure, both in the Atlantic and the Pacific and here over the Great Lakes. And if you intentionally go to a higher elevation, like 200 millibars, then you know you're not going to be seeing predominantly the polar jet. Instead, you'll see the subtropical jet. And it's possible that the jet structure over us has elements of both, even this far north in November. This is definitely a stronger jet feature off the Pacific coast at 200 millibars, signifying that what we were seeing at 300 was the bottom end of a subtropical jet core. It's not as obvious that that's the case here, but we did just see a cross-section through this thing, and it's a kind of a poorly put together isotac maximum. It's not well adhered to a strong tropopause gradient in PV or anything like that, so it's somewhat dilapidated no matter what the nature of its structure. But there's clearly subtropical influence upstream of that feature, and that will have some bearing on how things evolve early in the weekend, it looks like to me. So any questions or comments about some of the obs? Okay, let's see if this works. For some reason, Pete, I got a computer that doesn't like to stay on one page. Isn't that weird? I don't understand that. But I've somehow figured out how to manage it. And all my Genpack windows have disappeared, so I'll have to make them again as we go. That's unfortunate. I had it all ready to go and didn't quite do it for me. Okay. I don't usually start the forecast discussion by showing you the surface map, but the reason I'm going to do that today is because I want to talk about two features. One of them will be at this time, and the other one will be a little bit past this time. But those features are evident on the map. First of all, a cyclone that's really kind of weak. This is the 996 isobar right in there, just to the northeast of Maine. And you can see a pretty decent thickness contrast, cuts right through it. There's an S shape in the thickness field. So this is a nice developing cyclone, and this forecast precipitation in the spot where one might expect it on the eastern half of that developing disturbance. We want to see where this came from and then also where it's going to go in the near future. And this is now valid Monday at noontime. This is the other feature of interest, and I'll look at it structurally more than anything else, and that will be this cyclone that's just about to make landfall on the panhandle of Alaska. And I don't think you can read this in here, but this is the 1,000 millibar isobar, so they're every 4. That's 6, 2, 8, 4, 6, 2, 8, 4. This is 960 or 958 millibar low just before it makes landfall. And so the question is, where does that one come from? I'm intrigued by the forecasted precipitation having a maximum right in this thermal ridge, so I always like to look at the occluded thermal ridge and the structure of that. And then you can see it's got a nice warm front that extends out south of that triple point down off the coast of Washington and Oregon. There's precipitation along that, and then a cold front that goes all the way out to the west along the thickness gradient. And it's such an obvious warm edge of this region of cold advection. Suddenly it's uniformly the same temperature everywhere. So it's a really beautiful storm structurally. So let's take a look at that first, and then we'll trace back what we see on this storm on the East Coast. So as I said, unfortunately I'm going to have to run all these things again, but they should go pretty quick as I'm going. So I better do the cross sections first. Let's see, where am I? Let's do this first. Oh, come on. Oh, you know what it was? I'm running some scripts and they just get in the way, don't they? Yeah. All right, this is going to go backwards, unfortunately. Let me go to GD contour and I'll restore the last thing there. Okay. Nope, that's wrong. That's what I want. Okay, so I'll start here. I would have had it all just ready and prepared for you, but this is theta E at 900 millibars at that time, 18Z on the 23rd of November. So right when I showed you the surface map off the Aleutian Islands, off the, in the Gulf of Alaska. So this is a really nice picture of the, see what happened there? Oh, sorry, we've got time, so it won't be a big problem. Okay. So here's the warm frontal bundle of moist isotopes right along the coast, just about to hit the coast range. Here's the cold frontal bundle of them, and then here's the occluded thermal ridge, and I'll show you the cyclone center is going to be right here off Kodiak Island in just a minute. But look at that thermal ridge right in there. Isn't that nice? So let's put the thousand millibar heights on here. On top. So there's the cyclone center. This is about 960 millibars right there in the middle. And then here's the pressure trough that sits right on the occluded thermal ridge. Here's the pressure trough that's right on the warm edge of the cold front. Here's the pressure trough that's right on the warm edge of the warm front. Beautiful structure of this thing, wouldn't you say? And then it looks to me, if I take a cross section about like this, I'm going to have a nice slice through the occluded quadrant. But I want to first produce another map, and we'll do it on the fly. This is actually a good thing that we're doing this on the fly. Take the 303 degree Kelvin moist isotope. It's this one right here. In fact, I'll highlight that before we do this next exercise so you can see it a little bit better. Can't read with these glasses. Okay. Oh, I must have put in the wrong number. Okay, sorry, it's supposed to be the second one. So this is 303 degrees Kelvin theta E. It's definitely part of the cold front, it's part of the warm front, and it's embedded in the occluded thermal ridge. I'm going to create the topography of that for you before your very eyes. So watch this. All right. What happened? Oh. Level, all that stuff, right? What's the matter? Oh. Okay, here's the 1000 millibar position of the 303 Kelvin theta E isotrope. Now I'm going to just do it every 100 millibars and put it on top of the same map. So watch what you get when you start to do that. So G level equals 900. Don't clear this, please. And make the line color a different color. That's the 900 millibar position of 303 Kelvin theta E. Here's 800 millibars. Start to see some structure there. Here's 700. Here's 600. 500 and one more. So what you have here is every 100 millibars, where is the 303 Kelvin theta E surface? Here's a really steeply sloped surface to that thing. Every 100 millibars difference in height, and then it kind of flattens off a little bit. That's the cold dome for the cold front. Here's a less steeply sloped region, that's the warm front. And then look at this upward sloping, upward because it's going up to higher elevation and sloping back to the north and west. That's the occluded quadrant of the storm. And so if I go back to drawing a cross section right along here. Right through there like that. We're going to take a look at what this structure looks like. Not quite yet. So let's get a different color in there. So that's what the vertical cross section through the occluded quadrant looks like here. And look at this upward sloping maximum in theta E. Look how poorly stratified the air is here. And there's the warm front going up over the mountains, and here's the cold frontal portion of the structure out over the ocean. And if you really want to interrogate it, you can do other things like this. You can say, okay, what does the vertical motion look like there? And just the upward vertical motion. So here's where the air is rising in this cross section. And the big plume, not the most intense vertical motions themselves, but the biggest plume is right there in the middle of that occluded quadrant in that structure. This is forced perhaps partly by flow up the terrain, but also, as you'll see in a minute, very intense frontogenesis along the warm front. So that's the lower tropospheric ascent. But broadly speaking, the ascent's confined to the occluded quadrant, and then I'll put the frontogenesis on there. Look at that. Isn't that nice? So all this stuff is somewhat, it's not extraneous, but it's not really driving any of this. But look at this almost nearly continuous axis of frontogenesis along the warm front. It goes all the way to about 500 millibars. And the lowest part of it is most intense, and you get your vertical motion plume is initiated by that. Perhaps the second one has aided the production of this plume. So there's all kinds of relationships here and that you can see in there. So looking on the satellite on Monday will be interesting to see what that storm looks like. It ought to have a beautiful comma shape, a really nice kind of jelly roll structure where it gets wrapped up on itself. And this is part of the ascent and the cloud production that's going to go on in that part of the storm. And it's tied to these structures and some of the dynamics that are, some of it are left undescribed, but some of them are shown here by the frontogenesis. And you can do this on the fly. If you're looking around at storms and you have a tool that allows you to interrogate them with a little bit of spade work, you can really learn some interesting things about what's going on in these storms. Okay, so,
John,
yeah.
why are you using theta E instead of theta for this?
When I use theta E, I can get a better look at the full structure of both the temperature and the moisture. So I get a nicer, somewhat higher profile depiction of what the structure really looks like. It's doubtful that I'd have a really big dip in theta in this place. I'd have some. There'd be a little bit of a local warm bubble, but it's warm and moist, and so the theta E really comes down and gives you a really robust picture of that. So that's why I do that. Okay, let's go to this other feature on the, I'm going to back it up. And I'm doing it fast, so fast that you can't keep track, and that was on purpose, because I don't want to give away the punchline. But here's, let's get to a normal time, like 12Z on Saturday. So tomorrow morning at 7 o'clock, just about at that time, is the beginnings of a forecasted precipitation band. And notice where it is. It's right on the warm edge of a thickness contrast, and that is presumably with clockwise flow around the cyclone, anticyclone, pretty strong cold advection because the gradient's strong, and then suddenly the gradient weakens, so there's weaker cold advection, and that begins the process of frontogenesis, differential temperature advection. And this feature right here is 1028, that's 1024, so the flow is also somewhat frontogenetic there in central Missouri, but weakly so. But it's enough to produce a little band of precipitation there, with a maximum in the central part of Missouri. Not any obvious alternative for understanding why it's precipitating there. And I'm going to, all the way along, I'm going to be showing other such maps. This is, I want to just make sure I know what the time. 24-hour forecast. Let's go to the 500 millibar 24-hour forecast of vorticity on this panel. So there's our region of interest, right in here. Really hard pressed to find any upper level vortex structure that has anything to do with the production of that precipitation band. That's not uncommon. That tends to be the case, that a linear band of ascent is going to be forced by something that produces transverse vertical motions. That is, motions where the warm air rises everywhere on the warm side of a baroclinic zone and sinks everywhere on the cold side, not just in a local spot. But nonetheless, it's interesting to see there's no particular upper level support. In fact, we could also, interrogating it along the same lines, go to 300 millibars at that time. And, you know, there are people who are tempted to say, well, a precipitation band in this region is in the jet entrance region. That's hundreds of miles away. That's not related to this feature down here, nor is it related to anything to do with this kind of wimpy wind speed max over Arizona. So there's no obvious upper level support for the production of that precipitation shield at this early time. And I guess one last thing would be to look at 850 and just see if we can't see evidence for some differential temperature advection. Even here, it's weak. It's not non-existent. There's slight cold advection in southeastern Kansas, and then warm advection in northeastern Oklahoma. That's part of the region where maybe there's some weak differential temperature advection. Here's some cold advection in central Illinois, but suddenly when you get near Cape Girardeau, the flow is parallel to the isotherm, so there's a little bit of weak frontogenetic activity right in that spot, and that's about where you see the precipitation. But
John,
nothing here is very strong.
John,
Yeah.
you did show that the theta E isotopes did slope down to where that precipitation is. And they kind of folded under, so that it looked like there was a little conditional instability.
I didn't show theta E for this feature here though. Which one are you talking about?
Well, didn't you, when you showed the, where the, the topography of the theta E?
Oh, but that was for the Alaskan storm.
Okay, that wasn't over here.
No, it wasn't over here.
Well, then I could still point out though that I would guess, you're saying the jet isn't connected.
Yeah.
I don't know if I would agree with that, in the sense that front that's in the Midwest there.
This right here, this
Southern Illinois.
baroclinic zone?
Yeah,
Yeah.
I would imagine that the theta E lines, just visualizing it, would slope up toward where the jet is. And if the jet has an entrance region, which it does, where it's causing rising motion, wouldn't it draw that rising motion along those isotropic surfaces from the southern Illinois?
Well, it seems like a lot of work if the jet axis is about here to drag this air up and produce the precipitation right here, and then so the ascent has to be abrupt and moisture laden only here to produce that if it's connected to that circulation. I just think it's kind of remote. I don't know that it isn't true. I didn't investigate it, but I'm just saying it seems like it's kind of far-fetched.
It wouldn't be unusual for it to be moisture laden down there.
No, that's true. But I'm thinking of a more proximate in the vicinity forcing, and I think I see that in the frontogenetic forcing in the lower troposphere, although I don't have a calculation on this map. I do have one from tropical, but we can do that. I didn't intend to, but let's do that. So you can at least see that there's something going on there in the lower troposphere. I just gotta make sure I get the right time. So, let's see. That's a 24-hour forecast. Yeah, so that's a precipitation band. So let's look at this. 850 temperature advection and frontogenesis. And so there's a little bit of frontogenesis in the purple on an axis from southeastern Illinois across central Missouri. And so on the warm side of that axis, that's where the air is rising. So that's why I thought it was probably that forcing more than the jet and the stronger baroclinicity to the north.
Well, the frontogenesis isn't an isolated event, right? I mean, it's driven by something. I would think the overall mass shift that's occurring as that entrance region is moving by would communicate, the lines of communication are the theta E lines or the theta lines, which are going to connect from where the jet is toward that area. That's where they're going to go into the ground.
It's an arguable point. Yes, you could say that. Would it be the primary thing I'd pin my hat on? I wouldn't say that. I just wouldn't say that. I'd say, I see this, I like this better. And I bet if I kind of cross-section through here, I don't see a very deep structure because it's not very strong ascent, and so I'd have a hard time laying the blame on the entrance region of a circulation hundreds of miles to the north when I have differential temperature advection here that can just as well do it. Your point might be that because there's a jet feature there, it's going to influence the mass field in the lower troposphere, which might help induce some of that, the confluence. I don't disagree that there's some connection. I just don't think it's primary. So, anyway,
Well, I do, we can argue that later, right? I do think it's primary. I think if you got rid of the jet, that wouldn't happen in Illinois.
that might or might not be right.
Yeah.
Okay. So let's go forward a little bit here and watch what happens to that precipitation shield. It stays linear. This is 12 hours later. There's not really too much else going on. It's still kind of a linear band of precipitation in the forecast. But I think just after this time, it starts to take a different shape. It starts to look a little bit more like, wait a minute, there's a line here and then there's another piece that extends to the south. There's a little ripple in the thickness field. There was already a pre-existing minimum, local minimum in the perturbation pressure field. But that's starting to take shape into something that looks a little bit more interesting as perhaps a cyclonic entity. And so, let me make sure I'm at the right time here. This is the 36-hour forecast. So, if I go to 36 hours at 500 millibars, to try and get a sense of what might be responsible for that as a first guess. So it's right over central Missouri. There's a couplet of vortex structure. This is weaker and that's stronger, and that's often the case when you have some sort of convective motion. It's more amplified when the convection's intense. I'm not sure that's it, but there's a broad flat trough just to the west, so there is some tendency for there to be a little bit of upper level divergence over central Missouri. So now it starts to look like maybe there's some wave scale that's helping to put things together here. I don't know. And at 36 hours at 300 millibars, 30 hours. At 36 hours at 300 millibars, again, concentrating on central Missouri, the wave's a little more obvious at upper levels. I'm not sure that we really have a great influence from this piece, which is, I think, the bottom part of the subtropical jet, on the vertical motions right here. Maybe we're a little bit closer to this jet entrance region at this time, but that's about where I see that flat wave beginning to take what was a linear precipitation structure and turn it into something that might have a little bit more of a core circulation.
Well, you know that jet entrance region is
Which one?
actually moving toward the west, right? Relative to the wind.
This here?
Yeah.
Well, I don't know what you mean by that.
Well, it's a Rossby wave, so it's moving. It's actually propagating toward the west inside the wind, and so what we're seeing here is we're seeing this entrance region get closer to that event over time, and it's propagating toward that event. In other words, I think they're connected all along, and the connection is contracting and becoming more imminent. But I think they've been connected from the get-go. You don't agree with that, but that's just the way I see it.
I just don't see things that way.
Yeah, I do.
Okay.
But
All right. Well, it's interesting to have a different perspective. I have to think about it some more. So let's keep marching forward. This thing starts to look a little bit more and more like its own little entity. Now you've got a more pronounced local perturbation in the pressure field, more intense precipitation, starting to have a little bit more of a deformed set of thickness lines. It's starting to look like maybe something's grabbing onto this and turning it perhaps into a cyclone, but it's taken a long time to do it. And this is 42 hours. I'll go ahead to 48, where the tendency is the same, but not much more advanced. And then if we go to 500 at 48 hours, I think with the precipitation here over at the Boot Heel of Missouri and southern Illinois, so in this region, this feature aloft, this is a sudden appearance of a pretty intense upper vortex, but it's been in the northwesterly flow and likely developing in that flow for a while. It's still kind of remote from where things are really getting organized. But this is the thing that starts to get my attention. I say, okay, this might start to pick this thing up, because this region right here is still downstream of this broad wave at 500 millibars. So something's coming along that looks a little bit more likely to accelerate the cyclogenesis. At 300 millibars, that wave is amplified too at upper levels, and again, we're looking at something developing right about here. And so we're in a decent position. It's not primary position for that, but a decent position for that. And then, I think you can see this thing really does start to take on a little bit of a cyclonic look to it. Let's go one time back. This is now a 60-hour forecast valid on Monday at 0 Z. Come on. And trying to keep both of these things in the view at the same time. So here's where our asset is in western New York State. And this upper wave is amplified, but the main upper vortex is still a little bit farther to the west, but the wave is quite substantially amplified. So that's a decent place for cyclogenesis to stop taking shape. However weakly it might be doing so, but it's in a nice position relative to a deepening upper wave to the west. And I think at 300 you see the same exact tendency. Yeah, there's no really strong wind speed maxima to speak of. Here's the development region, and it's downstream of a really nice, almost textbook upper wave, and that's about the spot where you'd put your big capital D if you're writing. That's where you expect to have upper divergence. So it's starting to take on a cyclogenetic character, and as I said, it's slowly doing so, but you can see an S shape now in the thickness field, so there's some distortion of the thermal field in the vicinity of this circulation that's beginning to develop. And so if we keep going, get to, I think the time that I originally started the discussion was this one, 18Z, no, this one here, 18Z, when we first looked at the structure of the Alaskan storm. This is a 78-hour forecast. So let's see how things look now. So our main precipitation cloud head is right on the border of New Brunswick and Maine, so right in this region. That's immediately down shear of a really strong upper level wave. So this thing is about to just take off as a big cyclogenesis event, and we're at about 1,000 millibars for sea level pressure there. And I think at 300, it really is a repeat of this. So from here on out, we might not look at 300 millibars anymore, but I'll do it one more time. Yeah, it's just a strong upper wave. And right in the development region, you're immediately downstream. It's even slightly negatively tilted, which is good because that means there's some ridginess downstream. So this is a good development region. And it seems like, if we go back and think about what's happened at 500 millibars, it's been a gradual emergence of an upper trough. So I'll go this way. In the northerly flow, northwesterly flow of the Central Plains, this thing's eking out a subsistence existence to the south, and then the wave kind of comes into phase with that weak disturbance and starts to really rev it up. So now, if I just give you the punchline, watch what happens to this sea level pressure minimum. So it's 1,000 millibars. 12 hours later, it's down to 840,994, I think it says, just into maritime Canada. So that's a little bit of development. It's about a millibar per hour. That was 994. This is now 12 hours after that, 6 hours after that. And we're down to 988, so we're steadily at a millibar an hour for 12 hours up to that point. And then it goes to town. It gets in the next 24 hours, it goes from 988 to 964. So 24 millibars further a deepening in 12 hours. So this thing just gets collected by that upper wave. You can see evidence of that in the strong thickness field associated with this development, which now is at the mouth of the Labrador Sea. And so this thing is a really nice case of how the atmosphere does whatever it can do with all the various features that are floating around. You start out with what I consider to be a fairly weakly forced frontogenetic rain band that will, drop some rain across parts of the southern Mississippi Valley. It takes some time, but an upper wave emerges out of the northerly flow, and they're disjointed for a while in terms of their spatial relationship. They get themselves organized over New England. Once that organization occurs, simultaneous with going out over an ocean surface instead of a land surface at this time of year, that lowers the stability, and you get a huge response, and your cyclone gets down to the 960 range, and it does its part in keeping the North Atlantic thermohaline circulation going, because there's an enormous amount of wind raking over over that ocean and evaporating water and making the water more saline and colder, and then it sinks and drives the whole thing. So if you don't have these storms, I've always contended this, but ignorantly, because I don't know all about the oceanography, but it seems to me if you suddenly take these things out of the circulation, you can forget about the thermohaline circulation. It's going to disappear. So that's really neat, I thought, especially given the fact that it's not that much interesting weather across the continental United States leading to the holiday. It does look like, if we keep going, this is Wednesday, this is Thursday morning, so the holiday morning, the only place where you might not want to be, well, you certainly wouldn't want to be at the Trump Thanksgiving dinner. That's not going to be a happy place. But anyway, and maybe not in Pennsylvania either, but any place along the coast is where it's going to rain. Everywhere else, though, look at that. If we had normal travel, it would be a good day to travel on Thursday. So it looks like the holiday will be pretty nice. Not particularly cold. The 540 line is north of us, so I think it'll be probably even a little bit above Climo, but that means probably temperatures in the mid-40s. So pretty nice day on Thursday. So that's what I have today. Are there any questions or comments about that? And if we had more time, you could, and more tools at our fingertips, we could actually kind of fill in the gaps on some of these arguments too, but that's represent what I think is going on. Greg?
Pete, could you put up the jet stream map that I have?
Sure.
Yeah, you can get rid of anything you want.
Well, yeah, I guess I should ask you. I keep thinking Pete's control.
Well, I wouldn't be able to find it quick enough anyway, so.
Yeah.
Yeah, you had a really interesting event this week that we were talking about that one day.
Yeah. Just the top 160. Up there, yeah. Okay, so what you see flashing up there is the polar night jet is trying to appear. And at the same time the polar night jet is trying to appear up here, the southern hemisphere polar night jet is fizzling away. You can see at these at certain junctures here, it's still interacting with the subtropical jets in the southern hemisphere. But now we're starting to get this interaction in the northern hemisphere. And toward the end of the week, what's happening is this is not exactly interacting, but I'm curious about this lighter blue color on this this jet up here. Around the time you're seeing that bomb cyclone.
Yeah, can you stop right there too, Pete? I meant to make a mention of this, Greg. Maybe this figures in. Aren't positively tilted waves like this, don't they flux momentum poleward?
Yes.
Yeah, so it's kind of an encroachment in that sector of the northern hemisphere of the jet poleward to meet the burgeoning
I see.
polar night jet.
That's what I don't fully understand how this works, but you can see how robust this polar night jet segment is over here, and it's connecting with this, and now you're getting this subtropical push on the southern side of it. So it's like merging together in this vertical, in this vertical jet structure, where the jet right here is starting to be continuous from the lower troposphere all the way up to like 35 kilometers. Just a continuous jet. And there's some maxes in it, but it's a continuous feature. And this is trying to start doing something like that there. It's not, doesn't have its act together yet, but it's still doing it down here. So I think, I've said this before, I think when they start cooperating with each other and creating this vertical conduit, nothing's moving vertically. It's just the vertical thermal wind patterns align, and it reinforces the whole structure. When that happens, that's when we start getting big polar outbreaks. So I think this appearance of the polar night jet here now is foretelling that winter's about to happen. There's going to start being some major polar outbreaks, because once this happens, the secondary circulation around the troposphere jets, the secondary circulation there will start pushing the cold air to the south. It'll start driving the polar air southward in polar outbreaks and lifting or fluxing some more tropical air further north. I think once this happens, we do seem to get more of these tropical plumes reaching the Arctic. And they haven't done it for a long time.
Hmm.
But I think this will probably kick it off, and this here is a prog for the next week, so it may be a little longer than that, maybe into beginning of December, but this is starting to show that transition. And you said in the beginning that maybe that thing in Venezuela was a tropical cyclone. There's nothing on ECMWF or the GFS in the next 20 days.
Okay, so maybe
shows
it's finally
anything.
done.
It looks like it's over.
Okay.
And I mean, there's still some easterly wave structures going across the Atlantic, but they don't seem to have the ability to kick anything off in the Gulf anymore, so that seems to have ended.
Yeah, no, finally.
Finally, yeah. So I mean, I always like this time of year, looking at this evolution into this new structure that we're getting into.
It's a very interesting time. I agree with you. I think transition seasons generally are really of interest. This one here is the fall to winter has its own set of real interesting pieces, and one of them is the tropical influence that's, I think, enhanced compared to the winter to spring transition.
And it's, I think the general circulation connection here is really quite interesting. When Iota was here a few days ago, I was looking for the outflow, and there was no evidence the outflow was going into the northern jets at all. It looked like it was going south across the equator, and some of this down here might be actually the remnants of Iota going into the southern wave stream.
Interesting.
But Iota was one of the strangest tropical cyclones I've seen, in the sense that it didn't have a pronounced outflow jet anywhere that was producing a subtropical jet. It just didn't do it. That hardly ever happens.
Yeah, that's weird. That is weird.
And it wasn't Cat 5.
Yeah, right. How did it get away with that?
It's like it had very low inertial stability in the outflow, and it could go in all directions almost axisymmetrically. But if it went anywhere, it seems that the outflow is more going across the equator.
Wow, very interesting.
So there was some other connection at this time of year. The one thing we did see, and I think I texted you something, was an apparent Kelvin wave over the top of where Iota was. So I think Iota was associated with the movement of a Kelvin wave that was centered over the equator here, but it was feeding into that vertical circulation of the Kelvin wave. And so I think that's how it existed. Why did it exist this year and they don't have one every year? There's Kelvin waves all the time. I think the difference probably is the water's pretty warm. But other than that, I don't know.
Yeah, very interesting.
So it's an interesting past week. Iota is was it 30th or?
Yeah, I think it was the 30th one.
30th, yeah, that's the most tropical cyclones ever in the Atlantic basin.
Yeah.
So this is the record. It broke 2005,
Yeah.
and it ended on a bang
Yeah, with a Cat 5.
with a Cat 5.
Unbelievable.
So what kind of a year is that? Oh, Pete's got the upper.
Oh, I haven't seen these, Pete. That's cool.
That's
Yeah, so-
10 millibars.
Yeah, so here's the polar night jet. That's why I'm saying this thing is developing over here. You saw it connecting down. So this is the polar night jet here, and then if you do a cross section through here, what you'll see is a continuous set of isotechs going all the way down to 500 millibars. So, and of course there's a max up around 30 kilometers from the polar night jet, and then there's a max down lower. The one thing I look at that I think is plausible is the effect of the subtropical jet. The subtropical jet can come in between the polar night jet and the polar night jet up here and the polar jet down here. The subtropical jet can come in between, flip the thermal wind direction around. And I think that's how these subtropical ridges that come up, that's how they connect the two, or you connect all the way down into the polar jet. So the superposition of thermal wind regimes coming from the north and the south underneath, those connected down, and then that circulation lifts the cold air off the surface at the poles and mobilizes it to go south.
Yeah, you gotta write that up for me so I can read it.
Yeah,
about
that seems to be what's happening.
Yeah.
Anyway, there's something, fireworks do go off whenever we see these things connected.
Yeah, you've
They're doing
convinced
that.
me of that over the years. I don't deny that. I just don't understand it yet.
I don't understand either. I'm just, hypothesizing on some of these things.
Yeah.
But I like to look at this and see, because I see it happen all the time. It starts to get more predictable in my mind. I see this happening now. So
Yeah.
now I'm saying we're going to get these big connections that are going on.
Yeah, we'll see. That'll be interesting.
So,
Okay, thanks, Greg. Pete, I think we're all done. If there's any other questions or comments, that last map you were showing is really nice. You can see a sudden increase in the activity of deep cyclones all around the hemisphere. Really, really interesting.
The
So,
only other thing is Utkavik, I don't know if I'm pronouncing that right, but what used to be Barrow, Alaska, the sun set the other day and it won't come up again until mid-January.
Oh, yeah, yeah, that's right.
66 days of
of darkness. Yeah.
twilight, yeah.
Yeah. So that's pretty unbelievable. Tough to live up there, I bet.
Yeah.
All right, well, thanks everybody for your attention. And Pete, thank you as always for helping set up with the stream. And Greg, thanks for the discussion of the Jets. And we'll reconvene on the Friday, what is it, the 7th or something, or 5th? I don't know what it is, but you look at a calendar. The Friday after the Thanksgiving break, and we'll do it online. So, all right, see everybody. Have a good weekend.
Thanks, John.